You have learned in the unit A1, that is about kinematics, that if we release an object, for example a ball, in vacuum where there's a no any other force other than the force of gravity, then how the position of the ball varies. Let us revise it again. So we know that this ball will change its position like this, so that like in every next interval it will cover more distance than previous one, because the displacement will be proportional to the square of time. So anyways, this is a free fall motion in which there is only one force exerted on the ball. And what is that force? That is a force of gravity. So due to this force of gravity, because this is a constant force, if the ball is released near the surface of a planet, so then this force will produce a constant acceleration. And what is that? That is equals to mg over m, that is equals to g. So g is the magnitude of the acceleration. Because it's moving downwards, so we can say that vectorially this acceleration is negative 9.8 meter per second for Earth. So students, in this question we have to find out the rate of change of kinetic energy. Now why I'm telling you all of this, because according to this question an object falls from rest in vacuum, so its initial velocity is zero. So how it is linked with it, so let me explain you first of all what is the rate of change of kinetic energy. So rate of change of kinetic energy means that how the kinetic energy varies with respect to time when you will release a ball. And we know if its initial velocity is zero, then how its velocity or how its speed will change. So students, I tell you very categorically, if this is the speed time graph, then this graph will be like this proportional line for this motion specifically. But if it's a velocity time graph, then this line should be below horizontal, because velocity is negative due to the downward direction. Anyways, in both cases, in both scenarios, we know that the velocity is increasing. And how do you know that the velocity is increasing? We also endorse it from this equation, v is equal to u plus at. So what is a v? Final speed, that is 0 minus gt. So this is a velocity, this is a velocity of the ball. So what is the rate of change of kinetic energy? Because as the speed is increasing, that is proportional to time, so it means that kinetic energy is obviously increasing. And what is that? That is a final kinetic energy minus initial kinetic energy divided by the time that it took. So you can consider this is an initial position, and if this is a final position, so we know that now at this point it have a velocity negative gt. You understand? And what is a initial kinetic energy? That must be zero. So if we put the value in this equation, so 1 over 2 m into negative gt whole square over t, and that is so easy. Now you can solve it, and g square t square over t. And don't forget that this question is all about finding out the rate of the kinetic energy and then identifying what is a actual graph. Okay, now this students, this is a constant in this expression, which means that the rate of change of kinetic energy is directly proportional to time. So that means that it should be obviously option A for this question.